People always tell me to touch some grass, so that's what we're gonna do today. We start off by importing all the necessary files from our Minecraft project. This includes the shader class so we can easily work with shaders, the game class that initializes OpenGL and generates buffer objects, and the camera class so we can move inside our world. If you want to understand how they work, you can check out these Minecraft videos where I explained everything. If we run the game right now, we see this. You can't see it, but I'm moving the camera. The first thing we're gonna add is a single grass blade made out of 3 vertices. In other words, a green triangle. To make sure our grass doesn't float in the air, let's add the ground. It's gonna have its own buffers and shaders. And now our little triangle has a square friend. Let's add more grass blades using a nested for loop. This is 256 grass blades, and this is 4096 grass blades. And there we have it, a realistic looking grass. I think we did a good job. Thanks for watching. Okay, in all seriousness, we should probably make sure that they don't look like marching soldiers. To achieve that, we're gonna randomize their positions. There we go. It already looks a lot better. That is until you move here and look at it from this side. Yeah. We can fix this by rotating them randomly. And now our grass looks amazing from any direction. Just don't look at it from the top. Now I don't know about you, but I like my grass the same way I like my women. Anyway, we're making them thick. I'm just gonna add 2 extra vertices so it looks like a pyramid shape. I have so many jokes right now, but I don't want to get demonetized. Let's make them thinner. There we go. Let's also increase the amount of grass. Now I don't know about you, but in my opinion this looks better than the flat grass. Just for comparison, here's how it looked before, and here's how it looks now. Before, now. Before, now. Before, now. Well, to be honest, I was expecting more difference between them. But it does look good from the top. For the same reason, we're gonna add curves to our grass. Are you gonna come up with a complicated formula to make sure the grass is curved as realistic as possible? Yes. You're just gonna move the tip. I'm just gonna move the tip randomly. This has to be the best change we've made so far. The grass looks so real, I wanna eat it. Before we move on, I wanna do a little experiment. What will happen if we increase the curve limit to 4? Oh wow. I don't even know how to describe this. It does look interesting, not gonna lie. Now we all know that everything looks better with ray tracing. Unfortunately, my GPU is only capable of rendering YouTube videos with ray tracing. So instead we're gonna use basic lighting. To calculate the normals, first we draw a line that's perpendicular to the hypotenuse and has a length of 1. Now we need to find this angle, which we can find using the arctangent. All that's left to do is to use sine and cosine to find the normal vector. But since the values are close to being integers, we're gonna use integers instead. I just want the vertex array to look clean. Okay, these 3 represent the positions of the vertices, these 3 represent their normals, and these 3 represent their colors. Everything else is relatively simple. We add the ambient lighting to make everything dark, then we light up the faces based on the difference between their normals direction and the light direction. And if we run the game, we can see that it's working. Light here, dark here. Now let's turn around, mentally increase the number of grass, and then turn back. Okay, if I'm being honest, this is not what I was expecting. I mean, why does it look so bad? Is it because of high contrast? Let's try increasing the ambient strength. Nope, still looks like garbage. At this point I realized that since we're changing the vertices of the grass blades, we need to calculate the normals for each one of them. But we have a problem. Here we have the vertex shader and the fragment shader. We can't calculate them in the vertex shader since it works with one vertex at a time. And we can't calculate them in the fragment shader since we don't know which face the pixel belongs to. If only we had something in the middle. Something that works with polygons. Something that starts with G and ends with geometry. Something… Okay, here's our geometry shader. We take a triangle as an input and output 3 vertices. Here we're adding a curve to the grass. Here we're using the cross product to calculate the normal. And here we're setting the color for each vertex. And now we don't have to store everything in our vertices array. Okay, will it work on the first try? Well, it seems… Wait. What the hell is this? Why are they disappearing? And why does the lighting keep changing? After some thinking, experimenting, sweating, crying, sitting next to a window on a rainy day with coffee and thinking, what went wrong with my life? I figured out that I needed to take this and put it here, here, and here. Alright guys, this is it. We put so much effort into this. We had to learn a new concept. We had to fix the bugs. Now the question is, was it worth the effort? Was it worth the sacrifices that we've made? Well, let me tell you. Hell no! What is wrong with this grass? Why does it hate lighting so much? Before you say that it looks fine, please keep in mind that YouTube compression blurs the image so you're not seeing the pixelated edges that I'm seeing here. I think it's mainly because there is no anti-aliasing. Or maybe it's because our grass blades only have 4 sides. Or maybe I'm just dumb. In any case, I'm too lazy to fix that, so screw the lighting. I'm just gonna turn it off. Let's just keep it like this and move on. The last thing I wanna add is a swaying animation. I'm hoping to make them feel more alive and less static. Let's try moving their tips in a circle using sine and cosine. Would you look at that? This looks like fur, to be honest. I think we should randomize them even more so that they don't move in unison. We can do so by adding a random offset for each blade. Whoa. This is such a cool pattern. I can stare at it for hours. But sadly we're making grass here, so let's move along. Next we're gonna change the circular motion to elliptical motion. The x and z values represent the radii of our ellipse and the y value represents the offset. This will also lower their swaying angle so that they don't sway so wildly. And with that, we've officially finished making the grass. Look at it. It's so good. Let's try increasing the number of grass. I had to switch to using vectors for this to work. Come to think of it, maybe I should have used structures for grass blades instead of making a new vector for each attribute. I'm gonna leave that job to future me. Now let's see the result. Hope you enjoyed this demonstration as much as I did. Obviously this isn't over. I still have some ideas on how to improve this project, including this awful lighting. As always, the source code is in the description. Thank you to all of these awesome people who supported me on Patreon, especially Adam Kanzler, Kartoffelbauer 1000, and Wayne Rasmussen. But before ending the video, I wanna try turning the lighting back on. Maybe now it'll look good. Who am I kidding? Of course it won't. Oh well, like and subscribe and join our Discord server. Thanks for watching.